Hello Tweedledees and Tweedledudes, Miss Norris here again to talk to you today about measuring angles. Welcome to episode 2. So, grab a parent, grab a snack, and let's get started. The topics we're going to discuss in episode 2 are how degrees relate to fractional parts of a circle. The vocabulary we'll be discussing in this episode is degree. It's freezing in here. What temperature did you say it is? 30 degrees.
Congratulations on earning your degree.
Thanks. What? Oh, we're doing that kind of degree. Okay, all right, well, let's start over. Degrees. You've felt them, you've earned them, but have you measured angles with them yet? No?
You gonna learn today.
So, what is a degree? Just like when we measure objects using inches or centimeters, a degree is just a special unit of measure that we use to measure angles. So, who came up with measuring angles in degrees? Honestly, we don't know for certain. It's kind of a touchy subject here in the mathematical community. Some say the Greeks, some say the Babylonians, but some also say that the Greeks stole the idea from the Babylonians. But we're not going to insert ourselves into that math drama. This is the symbol for degree. You write this symbol after a measurement. So it would look a little something like this. We would read this as 90 degrees. Can you read this measurement? Did you say 180 degrees? Awesome. Do you remember in the last episode where I told you that a circle is made up of 360 angles? If not, you can watch that here. But for those of you who do remember, each one of those angles actually measures 1 degree. So if a circle is made up of 360 angles and each angle measures 1 degree, how many degrees do you think are in a circle? Did you say 360 degrees? Awesome! Now that we know that circles are made up of 360 degrees, let's look at some other geometric figures that we've seen before. Recognize any of these guys? You do? Angles, exactly right. If you didn't know what these were, you can watch that video here. In our lines, rays, and angles video, we learned how to classify angles based on their size, either as a right angle, straight angle, acute angle, or obtuse angle. What I didn't tell you guys in that video was that each one of those angles has a measurement that makes it what it is, the right angle. We know the right angle as the angle that forms a square corner. But a right angle is also known for having an exact measurement of 90 degrees. The straight angle is known for forming a straight line. But what you might not have known is that the straight angle has a measurement of exactly 180 degrees. Acute angles are known for being smaller than a right angle, but what you might not have known is that an acute angle is known for having a measurement as small as 1 degree all the way up to 89 degrees. That's 89 different measurements, but only one classification. Obtuse angles are known for being larger than a right angle, but smaller than a straight angle. What you may not have known is that an obtuse angle is any angle that has a measurement 91 degrees up to 179 degrees. So just like acute angles, obtuse angles have many different measurements, but only one classification.
Miss Norris, if those angles that you talked about have specific measurements that make them acute, right, straight,
obtuse.
When we learned about triangles, we also learned about right triangles, acute triangles, and obtuse triangles. Does that mean that they have specific measurements too?
You are exactly right. Let's talk about triangles. In the video, Classifying Triangles, I taught you guys how to classify triangles based on their angles, but not by the measurement of their angles. What kind of triangle is this? Did you say a right triangle? Awesome! What I want you to know about this triangle is that while we know a right triangle is made up of one right angle, that one right angle has a measurement of 90 degrees. And the other 2 angles that make up this triangle are acute angles, so they're less than 90 degrees. Let's look at one more right triangle. Notice that it has one right angle that measures at 90 degrees and 2 angles that measure at less than 90 degrees, which make them acute. Because of these measurements, we know that we can classify this triangle as a right triangle. What kind of triangle is this? Did you say an obtuse triangle? Awesome! What I want you to know about this triangle's measurements is that it has one angle that measures greater than 90 degrees and less than 180, making it an obtuse angle, and 2 acute angles that have a measurement less than 90 degrees. Look at this triangle. if you notice, it has one angle that has a measurement greater than 90 degrees and two angles that have measurements less than 90 degrees. So, because of its measurements, we know that this is classified as an obtuse triangle. Okay, one more. What kind of triangle is this? Did you say an acute triangle? Awesome. But what I want you to notice is the measurement of these three angles. We know that an acute triangle is made up of three acute angles, but you need to know what that means. That means that each one of its angles has a measurement of less than 90 degrees. Look at this triangle. Notice that it has three angle measurements that are less than 90. So that means it has three acute angles, which makes this triangle a acute triangle. Awesome! In episode 1, we really focused on being able to look at a circle and recognize different angles inside of that circle, or the fractions of the circle.
Let's circle back.
See how we can use that to help us figure out the measurements of the angles inside those circles. Let's start with the easiest way to figure out what an angle's measurement is. If the fraction of the angle inside the circle has a denominator of 360, then whatever number is in the numerator is the measurement of the angle. So 10 over 360 would be a measurement of 10 degrees. And 45 over 360 would be a measurement of, you guessed it, 45 degrees. Make sense? Awesome.
So what do we do if it doesn't have a denominator of 360?
That is where you're gonna need to know how to generate equivalent fractions. I don't have a video on this yet, as of when I'm recording this video, but if you're watching me in the future, you might get lucky and I might already have a video on how to generate equivalent fractions. Let's look at 1/4 of a circle. We know this is a right angle, which we found out means it has a measure of 90 degrees. But what if we didn't already know that? Could we still prove that it's 90 degrees?
Why, of course!
Let's first take 1/4. We're gonna set it equal to something over 360. What is the relationship between 4 and 360? Well, we know 4 times 9 is 36. So 4 times 90 must be 360. And as we know, whatever relationship is happening on the bottom of a fraction has to happen on the top of a fraction. So if the bottom is being multiplied by 90, what do you think we need to multiply by on the top? Did you say 90? Awesome. So to figure out the missing numerator, we would take 1, multiply it by 90, and that would give us a new numerator of 90 degrees. An angle that is 90 over 360ths of a circle means it has a measurement of 90 degrees. Awesome. Let's look at 1/2 of a circle. We know that this is a straight angle, and we know a straight angle measures at 180 degrees. But what if we didn't know that? Could we prove it?
Yes! Yes, we can!
Let's first take 1/2 and set it equal to something over 360. First, we have to figure out what is the relationship between 2 and 360. Well, we know that 2 times 18 would give us 36. So we just put a 0 on the end to show that 2 times 180 would actually give us 360. So since 2 times 180 gives us 360, whatever we do to the bottom of the fraction, we have to do to the top. Awesome. So now what we're gonna do is take 1, multiply it by 180. What's 1 times 180? 180. An angle that is 180 out of 360ths of a circle has a measurement of 180 degrees. Awesome. We could have also found that by taking 360 and dividing it into halves, or by 2, which would have also given us 180. Okay, one more, but this time I want you to figure it out. So if you need to go grab a piece of paper, pencil, or an expo marker, just pause the video and then play me back when you're ready. This is 1/3 of a circle. I want you to calculate this angle's measurement. First, you're gonna wanna set up 1/3 as being equal to something over 360. Now I want you to find the relationship between 3 and 360. Make sure you pause the video to give yourself time to figure that out. Did you figure out that 3 times 12 gives you 36? And then did you just throw a 0 on the end to know that 3 times 120 is 360? Awesome. Now I want you to apply that same relationship that you found for the denominators to the numerators. What did you get? Did you say 120 out of 360ths of the circle? Well, if you did, what's your measurement? Did you say 120 degrees? Great job! Let's review. How would you classify this angle? Did you say a right angle? Awesome, why? Because it measures at 90 degrees. How would you classify this angle? Did you say a straight angle? Why? Because it has a measurement of 180 degrees? Awesome. How would you classify this angle? Did you say an acute angle? Awesome. Why? Did you say because it's less than a 90-degree angle? Awesome. How would you classify this angle? Did you say obtuse angle? Awesome. How come? Did you say because its measurement is greater than 90 degrees but less than 180? Awesome. How would you classify this triangle? Did you say a right triangle? Awesome. How would you classify this triangle? Did you say an obtuse triangle? Awesome. How would you classify this triangle? Did you say an acute triangle? Awesome. Don't forget, when you're doing practice by yourself, if you forget how to actually calculate your measurement, you can always come back to this video and rewatch it a couple times just to make sure you understand. But just remember, whatever you do to the bottom of a fraction, you've got to do to the top. I think you guys have got it. I'll see you on the next one when we dive into Measuring Angles episode 3. Bye guys.